Imagine our world without concrete. No bridges spanning rivers, no high rises shaping skylines, no hospitals, schools, ports, or homes at the scale modern society depends on. At the center of this development lies cement, the binding material of concrete, and for more than a century, ordinary Portland cement or OPC has powered global construction. But there's a cost. Today's cement production is responsible for roughly 8% of global carbon dioxide emissions, making it one of the largest industrial contributors to climate change. And this is not a minor side effect of progress, it is a structural problem built into the way conventional cement is made. The main source of this problem is clinker, the most carbon intensive component of cement. Producing clinker requires extremely high temperatures, around 40 and 50 degrees Celsius, and releases large amount of carbon dioxide both from fuel consumption and from the chemical decomposition of limestone itself. Traditional strategies such as using fly ash or slag have helped reduce clinker use, but those materials are limited in supply and cannot meet global demands on their own. And now the question is no longer whether cement must change. The question is how do we make it change at scale?
Our answer is LC3, Limestone Calcined Clay Cement. LC3 is not an experimental fantasy material. It is a practical, low carbon cement system designed to replace a major portion of clinker with materials that are abundant, affordable, and already widely available. A typical LC3 blends contain 50% clinker, 30% calcined clay, 15% limestone, and 5% gypsum. By redesigning the recipe of cement itself, LC3 cuts emission while still delivering the performance modern construction demands. What makes LC3 especially powerful is that its solution is both simple and scalable. Let's break it down into three parts: sourcing, process, and chemistry. First, sourcing. LC3 uses kaolinitic clay and limestone. Unlike many conventional supplementary cementitious materials, these are not scarce industrial byproducts. Clay is one of the most widely available material on earth, and research shows that even clays with around 40% kaolinite can perform effectively in LC3 systems. In many cases, these clays may even be available near existing cement plants. For Pakistan and especially for us in Karachi, this sourcing advantage makes LC3 even more compelling. Pakistan has substantial kaolin clay reserves, including deposits in Sindh, and recent studies have already identified multiple local clay sources suitable for LC3, making the technology locally adoptable and highly practical. Second, process. The clay is calcined or heat treated at around 700 to 850 degrees Celsius. That is far lower than the temperature required for clinker production. This lower temperature process significantly reduces energy demand and emissions. Even more importantly, LC3 does not require exotic manufacturing infrastructure. The calcined clay can be produced using conventional industrial equipment, including rotatory kilns and other standard calcination systems already common in the market.
Third, chemistry. When kaolinitic clay is calcined, it forms a reactive material often referred to as metakaolin. This reacts with calcium hydroxide like a pozzolan, but LC3 goes one step further. The alumina from the calcined clay also reacts with limestone to form carboaluminate hydrates, along with other hydration products. These reactions refine the pore structure, densify the matrix, and contribute to strength and durability. In other words, LC3 is not just cement with something removed. It is cement with a smarter internal chemistry. And that brings us to the most important question. Does it actually work? Yes. Studies reported from LC350 shows mechanical properties comparable to plain Portland cement with strengths reaching similar levels from about 7 days onward. Industrial trials in Cuba and India have also shown that LC3 can be used in standard applications with similar water to cement ratios and without requiring highly specialized handling. This means LC3 is not only technically sound in the lab, but also feasible in real construction practice. In some aspects, it performs even better. LC3 shows a highly refined pore structure and excellent resistance to chloride penetration that is a major durability concern in reinforced concrete. In fact, studies have reported chloride diffusion coefficients for LC350 to be about 10 times lower than those of plain Portland cement for bridges, coastal infrastructure, and other exposed structures that can translate directly into longer service life and better protection of reinforcement.
Environmentally, the case is even stronger. Because LC3 reduces clinker content so substantially, it can deliver around 30% lower CO2 emissions with a pathway toward 40% reduction. And when one of the world's most widely used construction material becomes even one third cleaner, the global impact is enormous. This is why LC3 matters beyond the laboratory and beyond the cement plant. It aligns directly with the vision of building resilient infrastructure, creating more sustainable cities, and expanding access to lower carbon construction using materials that are realistically available in developing and developed regions alike. Even the broader green construction discourse around LC3 has been tied to SDG 9 through industrial innovation, SDG 11 through more sustainable urban development, SDG 12 through more responsible material use and production, and SDG 13 through direct carbon emission reduction. We often think sustainability requires sacrifice. LC3 shows that in engineering, it can also mean redesign, redesigning the binder, redesigning the process, redesigning what we accept as normal in construction. Because the future will still need concrete. The real challenge is making sure that concrete still has a future. LC3 gives us that opportunity, a cement that is lower in carbon, strong in performance, practical in production, and global in relevance. We do not need to stop building, we need to start building better. And that is why we believe limestone calcined clay cement, LC3, is not just an alternative to conventional cement, it is a smarter foundation for the world ahead.